So today we're going to cover section 2. We've split section 2 into 2 days, so today is 2A. So today we'll talk about functions, and for an equation or something to be a function, for each x value there's only one y value. So if they give you a list of ordered pairs, what we're looking for is to make sure that the x's do not repeat. The y values of the ordered pair can repeat. We're also going to learn this new notation. It's called function notation, and it's read as f of x. So just think of function notation as a fancy way of saying y equals. So for example, we're used to seeing equations like this, y equals x plus 1. Now instead of putting a y here, they're going to have f of x equals x plus 1. So it's just a fancy way of saying y equals. And what's going to start happening is you're probably going to be asked to graph more than one equation on a graph. So instead of labeling each separate line as y equals x plus 1, y equals whatever it is, you can add a different letter. So they might give you another function, and then they'll change the letter to distinguish between the equations. But again, no matter what the letter is, if it's got a letter and then a parentheses with a variable in it, that's just function notation. And again, you could replace that function notation with a y equals if need be. So let's go ahead and take a look at some ordered pairs, and let's see if this list of ordered pairs is a function or not. So again, in order for a relation to be a function, we need to check all of the first numbers in our ordered pair, because remember, the first number is x, the second number is y. Because all of these x's are different numbers, you would say, yes, this is a function. But on number 2, if you take a peek at all these x's, as soon as you get one that repeats, you stop and you say, no, this is not a function. So all of the x values need to be different. The y values can repeat. So if I had something like 1, 2, 2, 2, 2, this would be a function because my x's are different, but the y's could be the same. Now 3 and 4, these are mapping diagrams. And again, if you wanted to turn these into ordered pairs, you could. You could show that 1 matches with 2 or maps to 2, -2 to the 4, 3 to the 1. All you're looking for in this is to make sure that there's only one arrow coming out of each x value. So this one would be yes, because notice when I made them into ordered pairs, all of my x values were different. Now the next one, notice this -2 here. This has 2 lines or 2 arrows coming out of it, so this would not be a function. Again, if you wanted to list it as a group of ordered pairs, you would have -2 going to 0 and to the 1. So because the -2 repeats, it's not a function. Pretty good? Let's try the vertical line test. So 2 more ways to determine if something's a function. So far we looked at a mapping diagram and a list of ordered pairs. We can also determine if something's a function by doing what's called a vertical line test. So if you draw a vertical line anywhere on your graph, if it touches your graph at more than one point, then it's not a function. So for example, now you're not trying to make it work, you're trying to make it fail. So all linear functions are going to be, all lines, straight lines are going to be functions. Same thing with all of your quadratics, they will also be functions. So if I were to draw and graph a line, and then if I wanted to test it out to see if this is a function, then I would take a vertical line and I would draw it straight down. if this vertical line hits my graph more than one time, then it's not a function. Now, I'm not trying to make it work. I'm trying to see if it'll fail. So again, no matter where I draw my vertical line, notice it's only touching that red line once. Let me draw you a graph that would fail or would not pass the vertical line test. Let's say your graph looked like the letter C. Soon as I draw my vertical line down, notice it touches it here and here. So this would not be a function. So basically, if you have just an x with no exponent and a y with no exponent, all of those are going to be functions, unless it's a vertical line. Now, if it's a hyperbola like this graph here, this is going to involve a y squared. So if your y is raised to an even power, then it's not a function. So C's, even a graph of a backwards C, this would not be a function because when I draw my vertical line, it's hitting it here and here. Same thing for the graph of a circle. If you were to get a picture of a circle that was graphed, this would also not be a function because as soon as you draw your vertical line, it hits it here and here. So if you draw any random vertical line down through your graph, if you can find a spot where it would touch it 2 times, then it makes it not a function. Then if you're given an equation, if your y is raised to an even power, meaning like a y squared, then it's not a function. Also, if y is in absolute value or if you've got something with a radical, not a function. So let's try determining something is a function from an equation. So notice this one, I could rearrange it by subtracting x squared and sort of try to get this into y equals mx plus b form. But actually this is quadratic. Notice the exponent is on the x. The graph of a quadratic is going to look like this. Like this would be something like this. This passes the vertical line test because that shape of that U is sort of slanted out. So no matter where I draw my line, it's only going to hit it one time. So all x squareds, as long as the y isn't squared, will be a function. So this is yes, it is a function. However, the next one, notice it's got a y raised to an even power. This one will not be a function. Even if I try to rearrange it, you're going to see that you're going to get y squared equals x plus 1. If I were to solve for y, I'd be square rooting both sides. So this is not a function because all you really had to look at was the y squared. Same thing on the next one. Y is raised to an even exponent, so this one's not a function. This next one is also quadratic. If they want you to solve for y, this is what you would do. But my y is not squared. I don't have any absolute value, so yes, this is a function. Now we're going to evaluate functions. All right. Yes. All right. So now what we're going to do is evaluate a function. So again, instead of saying y equals, they're going to have a function like this, f of x. Let's say it's x minus 1. Then what they're going to do is they're going to tell you what value of x that they want you to replace x with. So for example here, if I have an x, a f of 4, wherever I see x, I'm going to put in a 4, and then I do the problem. So f of 4 equals 3. This actually turns this into ordered pairs if you had to graph things. This would be the ordered pair 4, 3. Because again, remember this function notation, this is really y equals. So if I were to plug in 4 into this, I get y equals 3. Remember, this was x. I can turn it into an order pair. So let's practice this. Now, notice I've got two functions here. I've got the f of x function, and I've also got the g of x function. So you need to pay attention to the letter in front of the number that's in parentheses. So for the first 3, I'm using the f of x function. So I'm going to take my x squared plus 3x plus 1. Every place that I see the letter x, I'm going to replace it with a 0. So I'm going to be evaluating 0 squared plus 3 times 0 plus 1. This gives me f of 0 equals 0 plus 0 plus 1 is just 1. Again, if they ask you to write it as an order pair, you could write it 0, 1. Because again, remember, the number that's in the parentheses is the x. The answer you get after you do the problem is the y of the order pair. Let's try the next one. Again, this time I'm going to plug in 1 to the same equation. So I'm going to be doing 1 squared plus 3 times 1 plus 1. 1 plus 3 plus 1 gives me 5. So f of 1 equals 5. Again, if they ask you to write it as an order pair, it would be 1, 5. Let's try the next one. Again, I'm still using the f of x function. So I'm using still the x squared plus 3x plus 1. But this time I plug in -1. Now be careful when your x value is a negative. So really what I'm doing here is -1 squared plus 3 times -1 plus 1. -1 squared becomes +1. And then +3 times -1 is -3. And then now I'll just work left to right. +1 minus 3 is -2 plus 1, -1. So f of -1 is equal to -1. Again, if they want it as an order pair, it would be -1, -1. Now we're switching it, and we're going to use the g of x equation. Now be very careful when there's a negative sign in front of one of your variables. So when I go to plug this in, the negative sign is there, but then the 2 goes in here for the x. Over here, same thing. And now I'm going to evaluate 2 squared. I get -4. Because again, this exponent is only going on the 2, and the negative sign falls down. Then +8 plus 1. I'll work left to right. -4 plus 8 is 4, plus 1 is 5. So g of 2 is equal to 5, written as an order pair, 2, 5. For the next one, this time I'm replacing t. So really all I'm going to do is change all those x's to t's. So it's just going to become -t squared plus 4t plus 1, and I'm done. So that's what g of t equals. I'm not trying to make it a value because I don't know what t is. Now the next one, I'm taking out x and I'm replacing it with x plus 2. So just to write it, so g of x plus 2, -x squared, just rewrite this thing. So now I'm taking out all of these x's, and in its place, I'm putting this. So -x plus 2 squared plus 4 times x plus 2 plus 1. I have to simplify this. I have to FOIL and combine like terms. So I'm going to first FOIL this thing. Now, unfortunately, I'm still seeing people that are just squaring the x and squaring the 2. Whenever it's a binomial squared, you either need to memorize the pattern or you need to write it 2 times and FOIL it. This becomes x squared plus 2x plus 2x plus 4. If you only square the x and square the 2, you're missing out on that middle term. So a lot of people are still messing that up. Do not just square this and square this. You've got to write it 2 times and FOIL it or memorize the pattern. So now this becomes negative, and then the x squared plus 4x plus 4. And then over here, I'm going to distribute the 4. So plus 4x plus 8 plus 1. Now I have to distribute this negative sign, or think of this as a negative 1 that I'm multiplying everything by. Now I'm going to go back and add all my like terms. So I can add negative 4x plus 4x. Well, these are gone. Then I'm going to go back and get my constants. Negative 4 plus 8 plus 1. Negative 4 plus 8 is 4, plus 1 is 5. So that gives me a 5. And then I still have the negative x squared in the front. So g of x plus 2 equals this. Okay, if you want to write it as an ordered pair, you would do x plus 2, comma, negative x squared plus 5. So you just take this, put it here, and then take the answer, put it here. Let's do some more with an h of x function. Just a new function. So this time we're doing 10 minus 3x squared. But I'm going to replace for the first one a 2. So I'm going to do 10 minus 3 times 2 squared. Again, do not multiply first. Do the exponent first. So 10 minus 3 times 4, I get negative 12. And then I get negative 2. So h of 2 equals negative 2. Order pair, 2 comma negative 2. H of negative 4. So 10 minus 3 times negative 4 squared. Again, do the exponent first, turn that into a 16. And then now multiply, and now subtract. So h of negative 4 equals negative 38. Order pair, negative 4 comma negative 38. Again, replace this whole thing for x. So 10 minus 3 times x minus 1 squared. Again, follow order of operations. We're going to do the binomial squared first, then we'll multiply. So I got to FOIL this thing, or again, memorize the pattern. So 10 minus 3 times x squared minus 2x plus 1. I'm now going to distribute negative 3x squared plus 6x minus 3. Only like terms I have are the 10 minus 3. So final answer here, negative 3x squared plus 6x plus 7. So that's what h of x minus 1 equals. Again, if they want you to write it as coordinates, you would write it like this. Take a look at that one. So now notice this time I've got 2 different equations going on here. However, it's still the same function. So what I'm going to do here is I need to decide which equation to use based on these restrictions. So when my number is less than 0, I'm going to use this equation. When the number in the parentheses is greater than or equal to 0, I use this one. So I got to take a look and see. My number here is -1. So is -1 less than 0 or greater than or equal to 0? I can see that it's going to be less than 0, so this is the function equation I'm going to use. So I'm going to take x squared plus 1, replace x with -1, do the math, 1 plus 1, and f of -1 equals 2. As a coordinate, -1, 2. Now I'm actually going to graph this also. So I'll graph it after I do the 3 functions here. Next, I got to see, where does 0 fit in? So that's going to be into the second equation because it's greater than or equal to 0. So the equation I'm using is the x minus 1. Maybe I can do that one in blue. So then I plug in 0 minus 1 and I get -1. So f of 0 equals -1 as a coordinate, 0, -1. Now I have x equals 1, and again I'm going to use the same equation. X minus 1, plug in 1, and I get 0. So f of 1 equals 0, and again the coordinate is 1, 0. Now, if you think about these 2 equations, the first one, again, think of f of x as a fancy way of saying y equals, and then this one, y equals x minus 1. Well, we've already talked about the linear equations. If I were to graph this equation, this is in the form y equals mx plus b. I would start at -1. My slope is 1 over 1. So then I could rise 1, run 1. However, remember this graph is only for x values that are greater than or equal to 0. So I would only be plugging in 0, 1, 2, numbers like that. I could also plug in halves. So let's go ahead and graph that one. So let me come over here. So remember before, when we made graphs of these, I would start at -1 and then I rise 1, run 1. Now remember, when I would connect my points, I would have done this. However, remember, because of my restriction here, it's not the entire line, it's only going to be from the 0 up. So that's that piece of the function. It's only for x values that are 0 or bigger. Now to get the left half of the graph, which are the x's over here that are less than 0, again, I can use my -1 here. See how I did it in red? I could graph this order pair, and I could put a point here. Now, I still need to fill in. If you realize, I know we haven't talked quadratics. However, this is a quadratic, and it's going to look like a U shape. Or if the number in front of x squared were negative, it would be an upside down U. Now, I still need to see how this restriction here was all numbers less than 0. I could plug in a -1/2, and it would be true. So what I'm going to do is I'm going to plug in the 0 to this, and I get y equals 1. But when I go to graph this, I'm going to put it as an open circle because of the x is less than symbol. Remember, that was the open and the closed circles. So I'm going to put an open circle here, and then it goes up like this. So what you're doing is picking numbers that are 0 or less, plugging them into this equation to get the graph. Whenever it's an x squared graph, the graph will look like a U. However, the right side of the U isn't using that equation. It's using the linear. Now I know the graphs are a little bit challenging. We will practice this some more. But the left half, the red part of the graph, came from the first equation. And then the blue came from the second function. And we piece it together. If there's time at the end, I'll do another graphing example of the piecewise. Let's go on and try the rest of the notes, and then we'll go from here. All right, so the other day we learned that in order to find an x or a y-intercept, remember you plug in zeros. So when we want to find the x-intercept, I set y equal to 0. When I want to find the y-intercept, I set x equal to 0. Here it wants me to find the x-intercept, which all I'm really doing is setting my function equal to 0. Because again, remember, this function here is really saying y equals negative 2x plus 10. So to find an x-intercept, I would set y equal to 0, and then I solve. So that's what this is telling you to do. You set your function equal to 0, so I take out the f of x, put in 0, and now I solve for x. So I'm going to add 2x. 2x equals 10, divide by 2, x equals 5. Again, we're going to write it as an ordered pair. So 5 was the x, and we plugged in 0 for y. The x-intercept will always have a 0 in the y position. We're going to do the same thing on number 2, but this time we have to factor it. So 0 equals x squared minus 5x plus 6. I'm now going to factor the trinomial. Factors of positive 6 that give me negative 5, and that will be x minus 2, x minus 3. Set each of the factors equal to 0 and solve for x. My first one is x equals 2. My second will be x equals 3. As a coordinate, 2, 0, 3, 0. So if I were to graph this, remember it's an x squared, so it's a quadratic equation. My y-intercept is going to be the positive 6. And then my two x-intercepts would be 2 and 3. So it would be here. So my graph would go something like this. The x-intercepts are where your graph touches the x-axis. If I would have done the linear one on number 1, again, my x-intercept is positive 10. So let's just say this is positive 10. And then from there, I could move my slope down to and over to the right 1, 2. So it would look like this. And then you can see that, let's say this is 1, 2, 3, 4, 5. It hits it at 5. So this is finding intercepts by plugging in 0. Let's try the next one. Again, set f of x equal to 0. I can either do the square root method here by adding the 16, or I can factor. It's a difference of 2 squares. Set each of the factors equal to 0. So x minus 4 equals 0, and x plus 4 equals 0. Subtract 4, x equals negative 4. Add 4, x equals positive 4. So the two x-intercepts are going to be 4, 0 and negative 4, 0. Next one, set it equal to 0. I need to try to factor this. Notice there's a greatest common factor of x. So I'm going to factor out a GCF of x. And now I factor what remains. Again, it's a difference of two squares. X plus 9, x minus 9. Don't forget about that GCF you pulled out, because now we take each one of the factors. This one, set it equal to 0. This one, set it equal to 0. And this one, set it equal to 0. I'm going to get 3 solutions, or 3 x-intercepts. That exponent on your original problem should tell you how many times it's going to hit the x-axis. Sometimes it'll bounce and hit it at the same number twice, but in this case, there are 3 different numbers. It's going to hit it at -9, +9, and 0. So my coordinates here are 0, 0, -9, 0, and 9, 0. And then number 5, again, set this equal to 0. So 5 minus 6x divided by 3 equals 0. I'm going to multiply both sides by 3 to get rid of that fraction. So now it's just 5 minus 6x equals 0. Add the 6x. 5 equals 6x. Divide by 6. X equals 5 over 6. As an ordered pair, 5 over 6, comma 0. 2 more examples and we're done. The next one is asking us to find what value of x would make f of x equals g of x. So all I'm going to do is take the 2 functions, set them equal to each other, and solve for x. So I'm going to take this f of x and set it equal to the g of x. So I'm going to do x squared plus 1, set that equal to 3x minus x squared. I'm going to move my x squareds together. I get 1x squared plus 1x squared is 2x squared. Then I'm going to move the 3x over because I'm going to turn it into a trinomial that I can factor. So now you can either factor by grouping or do guess and test. Let's do guess and test. Factors of 2x squared are going to be 2x times 1x. Factors of 1 are just 1 times 1, but they're negative because that middle term is negative. Now set each factor equal to 0. So 2x minus 1 equals 0, and x minus 1 equals 0. Add 1. 2x equals 1. Divide by 2. So my first one is 1/2. Add 1, and x equals positive 1. If they want coordinates, you'd plug it back in. They just wanted the x values. So 1/2 and positive 1. I'm going to do the same thing on number 2. Set them equal to each other. X squared minus 1. Set that equal to negative x squared plus x plus 2. Group your like terms. So I'm going to add x squared to both sides. Again, 1x plus 1x squared is 2x squared. Then move my x over and my 2 over. Subtract the 2. 2x squared minus x minus 3 equals 0. And now again I have to factor. Guess and test. Factors of 2x squared are going to be 2x times 1x. And then factors of 3 are going to be 1 and 3. I just have to figure out where to put that 1 and 3. So I'll try it there. That gives me 2x, 3x. That works. Set each of the factors equal to 0. add 3, 2x equals 3, divide by 2, x equals 3 over 2, over here add 1, and x equals -1. So the two values of x, when f of x equals g of x, are going to be 3 over 2 and -1.